Hello, welcome. We are going to work a problem together from the in-class notes. This video is made assuming that you have already mastered one-dimensional motion and that you have been introduced to two-dimensional motion in class, both the equations and the concepts. The best way to use this video is to watch and pause at certain points and see if you can answer the question yourself. The video is very similar to how we work problems in class. I will lead you to a point and then I'll ask you to think about what comes next. Please pause the video and do that good thinking. It will speed up your mastery of the material. If you come back from having decided on what you think the answer is and play the video again and it turns out you got it right, fabulous, proceed. If you did not get it correct, then I would ask, go ahead and watch the rest of the video, but make a note of it and follow up with me or your lab instructor or your tutor because questions like this can really help us to learn and master physics faster. It could be your idea was a completely fabulous one that was just another way to solve the problem. Recall, many of the problems that we work will have more than one correct route or answer. Or it could be that you have a concept or equation misunderstanding, and that's learning. And if we can sort it out, then the next time you encounter it, you'll get it right. So let's start by reading our problem and writing down our knowns. We've worked a few of these together now, so I'd like you to pause and see if you can write down the givens from this problem. I'm going to start by sketching the problem because sometimes that helps us to see some of the givens that may be kind of implied. All right, so I'm going to sketch in the initial velocity and draw in the angle, which I can identify. That was one of my givens. So I was given the angle, but I wasn't given the initial velocity because that's the thing we're looking for in this problem. All right, and that's 75 meters across. That's my change in x that I was given, or my range. And I will identify what I'm looking for. I'm looking for the initial velocity that the coin was given. All right, what else do we know about this problem that isn't stated? Pause the video and write down the other information that you know. I hope that you wrote down the acceleration in the x and y directions because we always know those for projectile motion. So what is the change in y, or the y displacement? For that, we need an origin. Pause and select an origin. So recall that we can put the origin of the Cartesian coordinate system anywhere we want, but it's often a good choice to put it at the very beginning or the very end of our problem. For this problem, I'm going to choose to put it at the beginning. Now that I've picked an origin, I can identify y initial and y final. So y final is 0 and y initial is 0. So 0 minus 0 is 0. In problems where we are given a value for v0 and we're given a theta, our next step would be to calculate v0x and v0y. We are given theta, but we're not given v0. So what we're going to do in this problem is just write v0x and v0y, leaving v0 as a variable. Pause the video for a moment now. We would like to calculate the x and y components of the initial velocity, so v0x and v0y, using things we know. Let's look at the equations and think about which equations we could use. Both equations B and E are tempting because they have accelerations in them, which we know, and they do not have v final in them, which we do not know. All right, so first we'll start with equation B. That's the one that starts with x displacement. And I'll write it out, and I'm going to note that the x acceleration is 0. So that whole term, that last term on the right side, will drop out. And then we will write down the corresponding equation for the y direction. All right, now let's substitute some of our knowns in. All right, now let's try to get organized. Let's look at what equations we have with things that we don't know in them. Let's identify them, and then let's count up how many equations we have, 4, and let's count up how many unknowns we have. So I'd like to identify them and write them all down there. So we have 4 unknowns. So that means they are solvable. I have labeled my 4 equations 1 through 4, and I'm going to show one way to solve this system of 4 equations. I am going to start with that equation that I labeled number 1, and I am going to solve it for v naught x. All right, I'm going to take what I just solved for v naught x then and set that equal to the v naught x in equation 2. And I will take that result and solve it for v naught. Next, I'm going to take the third equation, and I'm going to take the v naught that I just solved for and substitute it in as v naught into the third equation. All right, so now I'm looking at that sine of 45 degrees over cosine of 45 degrees and wondering if I can simplify it. Sine of an angle is opposite over hypotenuse, and cosine of an angle is adjacent over hypotenuse. So if I set those up as a fraction, I can see that sine of 45 over cosine of 45 is opposite over adjacent, and hey, that's also tangent. Tangent is opposite over adjacent. So I'm going to go back to my last equation that I was on and change the sine of 45 over cosine of 45 into tangent of 45. All right, let's go grab that fourth equation now. And what we're going to do is take the v naught y that we just solved for, and we're going to substitute that into the fourth equation for v naught y. All right, so those t's cancel out there, and I'm going to move the last term on the right side of the equal sign to the left side of the equal sign, and my goal here is solving for time. That's my last variable. And we calculate that the time is plus or minus 3.9 seconds. And of course, we'll take the positive root. Now we want to find an equation that has t in it, since we just solved for it, that allows us to calculate v naught, which is what we're looking for. And there it is in the middle of the screen. So we will finish this up by substituting in 3.912 for the seconds for the time and calculate our v naught, which is 27.1 meters per second.